The history of cartography is rich in tradition and in the advancement of technologies. With the introduction of computer technology and the use of map, chart, and database production, map production entered a new arena. Now with the creation of the digital chart of the world, another step is taken in the advancement of map making. This ambitious project is sponsored by the United States Defense Mapping Agency, together with the Canadian Directorate of Geographic Operations, the Australian Army Directorate of Survey, and the United Kingdom Directorate General of Military Survey. In 1989, the Defense Mapping Agency began development of a comprehensive GIS base map called the Digital Chart of the World. This project involves the creation of a digital geographic database known as the DCW, a display software package called VPF-View, and a standard vector product format that will be the foundation for GIS base map products for years to come. The DCW database has been developed to utilize a technology known as a Geographic Information System, or GIS. Let's first take a more detailed look at a GIS. A GIS is an organized collection of computer hardware, software, geographic data, and people assembled to capture, store, manipulate, analyze, and display geographically referenced information. A GIS data model involves storage of tabular data or attributes in association with polygons, lines, and points. GISs use these features as building blocks to represent objects on the Earth. The second major component of GIS databases, the attributes, are the stored characteristics of the objects. Attributes are usually stored in a relational or table format to allow relationships between these attributes to be effectively represented. Military and intelligence organizations in many countries use commercial GIS software packages for a variety of applications. But until the 1990s, each application required that a specialized database be built. This resulted in extensive cost duplication for GIS database development and the creation of GIS databases by various agencies in inconsistent commercial-specific formats. The demand for GIS data for military applications has resulted in ongoing database development projects at many producer and user agencies. The military requirement for interoperability between these agencies means that information exchange and database standardization efforts are critical. One of the DMA's missions is to promote interoperability between digital data users within U.S. military organizations and between the United States and its allies. Therefore, one of the primary goals of the DCW project was to develop a format to serve as a standard for all DMA GIS vector databases. This format is called the Vector Product Format, or VPF. VPF emerged from a variety of technical concepts, including relational data formats, topological data structures, and international standards for terms and definitions. The VPF is designed to allow all GIS vendors to use data in this format directly in GIS systems without requiring conversions. It will be used by DMA to ensure that future DMA GIS databases share a common format. The VPF standard will also allow GIS databases from other sources to share a common format. VPF has been adopted by the Digital Geographic Information Working Group, or DIGIWG. DIGIWG is a group of 11 NATO member nations that produce digital mapping, charting, and geodesy data. DIGIWG has adopted VPF as the vector relational format within its Digital Geographic Information Exchange standard called DIGEST. DIGEST is an emerging standard for GIS and automated cartography. But application of the vector product format and the DCW product is not limited to the military. Both the product and standard will be available to the public. This will promote the acceptance and use of the VPF standard. So environmental groups, schools, businesses, libraries, and universities may also use the DCW product. The DCW can be a GIS base map for a wide range of military and civilian applications. From transportation analysis to strategic planning, from military operations support to rainforest deforestation studies. Here the DCW is used by a GIS to display transportation infrastructure at a regional scale. The cities and railroad lines of the Western republics of the former Soviet Union are being thematically reviewed. A closer look at the city of Moscow can also be supported. Within a GIS, the DCW database can also serve as a strategic planning and statusing tool for military operations. Detailed planning and tracking of troop movements can be accomplished so that the positions of all units within an area of operation can be managed through time. The DCW can also form the basis for a wide range of regional environmental applications. Here, a thematic display of the Amazon River Basin illustrates the result of clear cutting. Closer analysis illustrates the possible effects of erosion on stream sedimentation levels. Essentially, any organization with global interest conducting GIS applications will find the DCW product helpful. A unique feature of the DCW was its development using a prototyping approach that helped reduce development costs and calendar time. The DCW was developed in 4 prototypes with approximately 75 participants involved in the review process. The product design stage allowed direct communication between DCW users and designers. Feedback was then incorporated into the product design of the next prototype. This design, feedback, change methodology was also used in the standards development process. Source materials for the DCW were developed by the 4 participating nations. These are the 270 operational navigational charts of the world, along with 6 jet navigation charts over Antarctica. The production process consisted of 6 steps. During the first step, feature positives were photographically created from negative feature separates, which are the basis for the ONC color printing process. Each chart has 12 to 25 feature separates depending on the number of categories of features. The feature positives were then prepared for optical scanning. The feature positives were scanned using raster scanning equipment combined with vectorization software to produce vector line files. During the third step, technicians used a GIS to build an initial data structure and edit any errors identified during extensive quality control process. Also during this step, the geographic data attributes were assigned to the features. Step 4 involved the translation and conversion of the geographic data from the production format to the vector product format. The database was then placed onto the CD-ROM media through pre-mastering and mastering processes. The final production step involved packaging of the CD-ROM disks and final quality control. The DCW data is held on 4 compact disks with read-only memory. Each disk contains approximately 400 megabytes of data. Disk 1 includes North America. Disk 2 contains Europe and Northern Asia. Disk 3 includes South America, Africa, and Antarctica. And Disk 4 contains Southern Asia and Australia. Significant data overlap exists between each disk. The DCW database product will initially be distributed with a demonstration software package known as VPFView. In the past, few digital products have included an effective way for the prospective user to review the data. The users had to decide upon the usefulness of the data by reading the documentation provided or expend the effort necessary to write software access routines. Now with the creation of VPFView, this is not the case. VPFView software will read and display not only the DCW, but other VPF databases. VPFView is written in the C programming language. It is designed to operate on microcomputer equipment using the DOS operating system. The recommended hardware configuration is a machine built using an 8386 chip. VPFView will also operate on an 8286 machine. A math coprocessor is required in all configurations. The software is distributed on both 3.5-inch or 5.25-inch floppy disks. The VPFView is designed to demonstrate VPF databases. It should not be confused with GIS software that is used for analysis. The DCW product alone provides only the database component of a GIS. Now let's take a closer look at the DCW database by using the VPFView.
the user first picks a geographic area of interest.
Since the DCW database contains thematically organized layers, one can display the geographic data by selecting features within layers, individual layers, or groups of layers. Each layer contains the attribute and spatial relationships for the geographic data within that layer.
The DCW includes 17 layers. For example,
drainage features such as lakes, perennial rivers, intermittent rivers, and other features. Elevation data, including 1,000-foot contours, supplemental contours, and point elevations.
International boundaries, subnational boundaries for 6 nations, and world coastlines and islands.
Transportation networks, including roads, railroads, and airports. Other cultural layers, such as urban areas, landmarks, and utilities, and other physical features such as swamps, sand, ocean features, and vegetation categories. The database also contains a World Gazetteer. When geographic names or portions of names are entered into the demonstration software, the locations of those places are displayed on the World Reference Map.
Regular database maintenance of the DCW is planned by DMA.
Whether your interests are military, scientific, environmental, or educational, the DCW provides a powerful global digital GIS base map. When combined with the Geographic Information System, the DCW database can be used to solve problems specific to global or regional applications that are limited only by the imagination. As a standalone tool, the VPFU software provided with the DCW creates tremendous educational opportunities. An additional result of the DCW project has been the development of standards which will allow data in a common format to be produced for years to come. It is anticipated that future GIS database products will be developed in the VPF format at many scales and resolutions. Data format consistency is now possible across organizational and national boundaries. And as GIS databases grow through the contributions of military cartographic agencies and the civilian community, the ability to solve complex scientific and military problems will skyrocket.